So hello everybody and welcome back to our GTB track at the A4Q Testing Summit. So we have the fourth and last presentation in our track for today, and I'm very happy to welcome Nils Röttger from Germany, and he will present today or talk today on testing with AI. How can AI support us? So Nils has more than 15 years of experience in the field of software quality assurance, and since 2008 he has been working with Imbus in Germany. Currently he's there working as a senior consultant and test manager for mobile testing and AI testing. He has also been active in a working group for the standardization roadmap AI at DIN, which is the kind of the German branch of the ISO. Currently is also writing a book for the new ISTQB AI testing syllabus, and therefore I'm really happy to have you here, Nils, and thank you to be here, and the stage is yours.
Okay, thank you, Florian. Yeah, what is my topic today? Testing with AI. How can AI support us? Let's have a look at the agenda. And first, I want to give a short introduction to AI. What is AI? That we have all the same view to this topic. And then we have a look at us as software testers, and how can testing tools support us in our daily business. And in the last part, we will look in the future. So yeah, let's begin. AI basics. Here I have two articles from a German website and a German newspaper. Yeah, the slides, the screenshots are in German, but it's not so important. I will talk about it. On the left side, we see an article about Corona and COVID-19 and how AI has helped to develop the vaccines. So there was AI included in the development process. On the right side, we see an article about scientists which want to recognize cancer, and therefore they want to use an AI. And they need only 2 hours to train this AI, and then this AI was it was possible with this AI to recognize cancer and X-ray images. So that is next are 2 examples for the medicine context where AI is involved today, not in the future, today. Another context is, of course, autonomous driving. I think I don't have to talk about so much about this topic. We all know that when we talk about autonomous driving, that we talk about AI. But I can use this picture for another context, and this is predictive maintenance. We see there a bus, or we can think on a truck or a tractor, and with predictive maintenance, we can have a short look in the future, and then the AI said us, okay, the bus have to go to the garage in 2 weeks, and then we need to renew the brakes, for example. That is predictive maintenance, and that is helping very much in the farming industry or in the industry itself. Okay, one last example, that is software development. And in software development, in some tools, there is AI involved right now, today. And yeah, if it's there, why it's not in our daily business, in the testing business, I will show at the end some tools we can use for make our daily business better and faster. That were examples where AI is working and where AI is involved today. And now I will have a look at some examples where AI is not so good or not so good working. So we have here the Microsoft Caption Bot. Some of you know it, this topic, but it's a good example why it's to explain why AI is not it's not God. Yeah, it's a tool. So here in April, what is this Caption Bot do? This Caption Bot wants to understand the content of a photo and try to describe what it is on the photo to see here. He's analyzing the photo, and then he said, okay, there, it's this and that. So here in April 2016, that was the first time. I'm not really confident, but I think it's a man in a suit and tie talking on a cell phone, and he seems not so lucky. Okay, it's okay. but it's not right. Right? Then 1.5 years later, he is sure, the AI is sure, I think it's a man wearing a suit and tie talking on a cell phone, and he seems not so lucky. And then in 2019, 2 years later, I think it's Barack Obama, okay, that's good, talking on a cell phone. That's not so good. Apparently, the AI continue to learn, but nothing seems to be a no-brainer. You apparently have to explicitly want to recognize a second face, a second person, a second human. So if the AI was trained to recognize one person, then it recognized only one person. And that, yeah, it's a good example of what can go wrong. Another example is this. AI cannot be fooled. We have a panda on the left side, on the right side a gibbon. No. On the left side we see a panda, on the right side we see a gibbon too. But the AI said on the left side is a panda, on the right side is a gibbon. And what have we done? We have put some noise on the left photo. It's very little noise only. So with our eyes we can't see the difference. But the AI is, for the AI, that is not more possible to recognize the panda. And this is also possible with audio. Here we see two wave files on the left side, on the right side, and there the noise is in the middle, and we put on the left side this noise, and then you see on the right side in the waveform that it's a little bit bigger in the middle, yeah. And it's like above, it's not so much noise. But the AI is, it's now on the left side, that's right, how are you? And on the right side, the AI said now, let's open the door. But it's not good, it's not the same. This is an error. And the last example where AI is not so good, perhaps, AI is, in this case, wrong, but the requirements for the AI was wrong. You can see right now.
Nice. Okay, Noel, you try now. One to your honey. Two black.
Two black.
Yeah.
So what I'll do?
Come again, Sash. Whoa. Two black over there.
What I have to do to get
What do you have to do to
so racial this thing is?
Yeah.
I have to use that piece of white. Let's say napkin. I'll show it.
Again. Bring up again.
Napkin again.
Right, put your hand out.
What's it called on a hand?
Man, the black man getting fight.
Black man getting fight
all over.
Okay, this is a very good example, I think, why AI projects need us software testers. Okay, let's have a short look at the brief history of AI to understand what is possible with AI and so on. In 1956, there was the Dartmouth Conference, and that was the first time that there was a field of research for AI established. Then from 1940 until 1950, there was the early days of AI, and there we have automated deduction techniques based on mathematical logic. Then from 1960 until 1980, there was the research in symbolic and sub-symbolic AI, and that was, of course, more automated deductive techniques, and the first time artificial neural networks. And we have Prolog. Some of you remember Prolog from the university. I remember it too. And it was the first programming language I hate. But of course, for AI projects, it's funny to remember this Prolog stuff. Okay, then 1980 until 2000, there was a real boom in knowledge-based systems in industry. And then there was a big disillusion and decline. Why was it? I will explain later. And then since 2010, there comes machine learning, and this succeeds. This success of machine learning leads to a lot of interest in the industry and a wide range of applications. Why was it? What is here in the boom, there was knowledge-based system and, of course, more mathematical models with probabilistic reasoning. And now since 2010, the machine learning problem. Why was the big success? Machine learning is artificial neural networks and statistical learning algorithms, and this both need very much computing power. And the breakthrough in the development of AI applications due to this large increase in low-cost computing power. I remember, 2000 about, I was in the Max Planck Institute in Göttingen, and there was a department, they want to compute some things, and then they bought 30 PlayStation 2, and then they combine these PlayStations together and calculate something on the graphical user on the graphic cards from this PlayStations, because it was cheaper than to buy a lot of computing power in a server farm or something else. Yeah, and that was the 2000 years, and now we have so much power that we can, every one of us can use our laptop, and that we can there calculate a neural network. And another thing is that we have now the availability of large amounts of data. I will come back to this amounts of data at the end of the talk. And this machine learning, this ML, that is typically that what is AI when media talks about AI, or the hype about AI in the newspaper and so on, that is mostly machine learning. Here we see a typical example of image processing of a artificial neural network, ANN, and how does this work? On the left side, we see the inputs, on the right side, the outputs. And process ANN, input to output, numbers. There will be calculated. There's some simple arithmetic with multiply, add, and so on for the numbers. Then we have some layers, input layer, hidden layer, output layer. And of course, we have the neurons. Between the neurons, we have the weighting factors and the neuron inputs. And there's it's a formula to calculate these numbers. And what we need for a neural network is an activation function that is part of the magic, comes from this, and this limits value ranges of the numbers, ensures stability, and so on, sets thresholds. All these things is from the activation function. There are lots of activation functions, but scientists have shown that it's not so important which one you choose. I think the most common is used sigmoid. Okay. Then we have the word deep neural networks. That is this one. There we have a big hidden layer in the middle. And here we have many more parameters and weights. And so we can massively parallelize this calculation and calculate more and more things. And it's more precise. The calculation is mostly on GPUs. That's the reason why so many GPUs are involved in AI projects. Here are two examples of deep neural networks. On the left side, we see YOLO. YOLO is a real-time object detection. When you drive with the autonomous cars through the streets and you want to recognize, you see it on the left side, the AI has to recognize there's a car, there's a street, and so on. There's another example of a very famous deep neural network is GoogleNet. You see it on the right. You can have a look after the talk. Okay, here is machine learning, and machine learning can be divided in or subdivided in different aspects. And here there are more, but here I have three on the slide. Supervised learning. That is when the results are known and we have many variants. For example, I have examples. Unsupervised learning, that is independent finding of correlations. So we want to find correlations. In reinforcement learning, there we have the reward and punishment for the AI. You see as a labyrinth, and if the AI goes the right way, then it gets a reward. It goes the wrong way, then it gets punishment. And then the AI is getting better and better in every learning step. So this is possibility subdivision. And here are the examples. Supervised learning, for the binary classification, we can have yeah, on the right side, banana and oranges, or think at the slide, one of the first slides with the cancer and the recognition of cancer, that is binary classification. Then we can have multiple classification. We have not only two, one, banana or orange, yes or no. By multiple classification, for example, handwriting, we want to recognize numbers or letters. And there's much more image speech recognition and so on. That is supervised learning. Then one more slide for not supervised learning, unsupervised learning. That is the classification, I said it. And there we want to do clustering, for example. You see it on the right. There we have 3 clusters, the green, the blue, and the yellow. We have only the input data and then the algorithm, and then there's the cluster. That is machine learning too, but it's not an artificial neural network. There's more for not supervised learning. For unsupervised learning, that is an error, I think, on the above there. Unsupervised learning, we have compression, principal component analysis, anomaly detection, autoencoder, that all are examples for unsupervised learning. One last slide for the basics of AI. How can we classify AI? Yeah, some terms for classifying AI. There's a huge topic. All the AI learning systems, they are very big. It's a very big bubble. Then in this, there's the machine learning. And then in this machine learning, we have deep learning. And there are some other bubbles. I said it in the beginning at the history slide: symbolic AI, expert systems, decision trees, evolutionary algorithms, and so on and so on. They are overlapping with the other bubbles here. So that was the introduction. Now we have an idea about AI. What is AI? What is possible with AI? Now let's have a look at us, at our software tester, daily business. Yeah, and what have we to do and what are the activities in software testing? And here we have the classical test process. We have to schedule the test tasks. We have to do analysis and evaluation of the test basis, design the test cases. We have to think about the test data, from where we get the test data. Perhaps we have to build test data, to build the test environments and so on. Then we have the implementation implementation in the middle of the test process. There we have to build the test procedures, the test scripts. Of course, we have to deal with the data there too. Then it comes to the execution. There are tests to do, automated or manually. We have to log, we have to evaluate, repeat, detect, and so on. Detect anomalies or detect bugs. And on the right side, for all the things in the test process, there's monitoring and controlling the test process. That is for every step: analysis, design, implementation, and so on. So how can AI help us here? How is that supposed to work? And do I really need this? Do I need AI as a software tester? It's a good question, I think. So let's have a look. Where can AI help in this test process? What do we have at the step analysis? We have requirements. Are the requirements consistent, complete, unambiguous? Are there test conditions, and so on? And yes, I think we see it later. There should AI can help. Then we have the test design. We have to specify the test cases and construct the variants, behavior or model-driven test design can we do. We have the test data, generate test data. We have the test coverage, avoid duplicates, and so on. I think we see some slides in the last 20 minutes. So yeah, AI can help here too, I think. In the implementation, of course, test scripts, test data. I said it in the beginning that software developers have tools with AI components, so we can use it here too. And then in the execution, in the automated execution, I think, yes, there will be AI tools. I'll show them later. But in the manual testing or exploratory testing, I don't think that AI can help us here very much. That is one of the only points here, I think, where AI is not so good, perhaps. We as human testers are needed, I think. But in the monitoring and control, of course, that is the thing with the data. We have so much data in monitoring and control, and therefore it's typical AI task, I think. Why is that necessary that we use AI in our daily business? Here we see the SDLC speed, the software, the speed software development life cycle, and it's getting faster and faster. And we get updates for the software not only after 1 year, after 1 month, after 1 hour. Now we are by minutes or seconds. And because of that, we need to be faster than we are right now, I think. And perhaps AI can help us there. The task is growing. We have more applications, more scenarios we have to test. We have to deal with in mobile testing. We have to deal with more devices, iOS, Android, and so on. We have more requirements for maintainability, performance, security. We have accessibility, and so on and so forth. And we, therefore we need to be faster than now. And perhaps AI can help us here. I think it can. So, I have to look at the time there. Okay. Then have a look at test tools. Where can test tools help us? And there I have some examples from the test process where test tools can help. So think on requirement analysis, and we want to find similar requirements or similar test cases, or similar user stories, similar epics. Here can AI help us, and we can use therefore speech analysis techniques, natural language processing. But then when requirements are collected collaboratively, it's possible. When existing requirements are extended, it's possible. And then we can build a similatory index. And this can help us to find similar requirements. We have a bachelor thesis from Daniel Körmer, one of my students. And it's working. It's not software right now. It's it's a version 0.0.1, I think, but it's working, and we can find similar requirements with this AI. And therefore, we are using some algorithms to calculate some things. I'm not so deep in this topic, but there are algorithms like work mover distance or word to vec. That heißt, we are looking at the word, and then we see it there. We calculate some numbers there. There are other models, BERT, Roberta, lemmatization, and so on. And this algorithms help us to decide, is this the same sentence or the same word? And with this we can find similar requirements or similar test cases and so on. And that can help us, I think, in our daily business if we are writing a new test case and then the software said, wait a moment, I think we have this test case. Have a look at test case 123. There is a similar test case, then we see it, and yes, of course, it maps, and then we don't have to write it again. Doing test execution is an example from one of our projects. So we have to test a digital water meter, and the test scripts are very long, and the pictures we can get there are very much, and therefore we need we are looking for idea how can we test that, and then we come to the conclusion, okay, perhaps we can do this with a neural network and with pictures. And then we have, okay, that's possible. And then we have decided to generate a test case which is running the whole night, do a lot of things, and we make every seconds or minutes, we take photos from this digital water meter. Then we have a raster on these photos, And with the neural network, we can now do some things there. We can recognize active segments. We can recognize if there's a malfunction or flows water in the forward direction that's not correct, and so on. There's a symbol there. Or we can see not inactive segments. There's a segment missing, and all these things can be done with AI. So this is a real project by us, and it's working. In defect analysis, we can use classification. ODC, that is orthogonal defect classification. And there we can use the history of our errors or bugs we have found. And then we can have a look at the new defects we find and do the mapping and so on. That is only possible when many defect messages need to be classified, prioritized. If we have only 2 or so, then it's not. There are a lot of things to do to get this working, and if there are only some bugs, then it's not need to do this with AI. And when existing data is incomplete, and we have to have weather time mapping goals, criticality, component, defect type, and so on, all these things. And then AI can help us to classify these errors. Therefore, we need a huge database with errors from the past. I have the example on the next slides. But attention, think on the automation bias. If you have learned the AI and there was only bugs, for example, with one function, then it's clear that the AI will find bugs with this function in the future and classify a bug on another function in this software perhaps not correct. So think on automation bias. So let's have a look at the future and some tools which can help you in your daily business. With a look at the time, I will not say something to every tool, but I will try to say something to one of the tools on this next slides. It's a giveaway for you. You can use all these links here, and then you can do your own research after the talk. Here are some tools. Clever Commit is a very good tool. This helps to decide if I have to do the commit or not. So whether or not a code change will introduce a new bug, and perhaps fix it. So fix this code, and then you can commit it to the branch. On test specification, test generation, there are some tools. For example, the test bench, there you can translate test cases if you have teams in the test bench is using DeepRecon there. Then you can translate the test cases for teams, for example, in Africa and in Germany, and then they can very fast work together. But the other tools are very good too. More tools for test specification and test generation. Botium is a very interesting tool if you deal with chatbots. For chatbots, you need many test data, and Botium can help you to generate this test data, and it can test automation do for chatbots. In test automation, I think this is there was the first AI components in test automation tools. For example, in Eggplant, I see it live in a conference, 2018, 19. And they have integrated model-based testing in their Eggplant tool. Yeah, and that is a little bit AI, and that is helping us to decide which tests we have to do, in which with the prioritization of the tool test cases and so on. other tool here in test automation context is UFT. And UFT is helping us with object recognition. And that is very, very interesting, I think. If there's a button in the application or in the mobile device, in the app, and we have to write a lot of code and do a lot of things that this button has to be pushed, then we can use this, and UFT recognizes as a button, and we do not to deal with IDs and so on. And that is, yeah, a very good tool, I think, too. Then in test case selection and optimization, there's the tool Scryer. And I said it some time ago, we need a lot of test data for the AIs, or we need a lot of data for AI to work. And here is an example from Siemens Healthineers. And to get this tool running and to get this tool working correctly and to get this tool to help the testers, they need 70,000 test cases, 400,000 commits, and a lot of more test executions. And all this they need for training, and then they get a predictive accuracy for failed tests with over 75%. So it's a good example that you get an idea how much how much data you need for your AI tools. It's similarly to the tool where you recognize the bug, the defect, and then the AI helps you to categorize the defect for you. So you need a lot of data to do the right things with the AI. And of course, we have regression tests, and there's many tools which help us to detect changes. Test AI, retest, test him, all these tools help us in the difference testing. Yeah? So which test cases I have to run? All of the 100 test cases? No, only this 20 because there was the changes. And then we can do only the test cases where the changes was. Okay. Is that also easy, like talk about it? No, it isn't. A fool with a tool is still a fool. And yeah, there are many claims made by manufacturers. Which metric do they use? I have to think about it, or we have to think about it before we buy this tool, before we use this tool. What is the data situation in our company? Do we have a lot of data? Do we have enough data? Do we have the right data? And then we have to do a comparison to the vendor use case. How does a tool scale in your own project? Is it scaling or not? And it's very important to understand how to use this tool. Do we need experts? Do we need a data scientist that we can work with this tool? Or is it possible for us as a normal software tester to work with this AI component in the tool? And last but not least, it's very important, I think, is the AI doing the right thing? Is the AI right with its result? If the AI said this bug is a high prioritization bug and it's a bug for the usability and it's a bug for this function and so on, and that is not matching, it's not true, then the AI tool don't help us. And think on the automation bias. Here, it's a very important tool. Let's have a look where the trend is going. And I think the trend will shift from execution to analysis with these tools. So we can do more things with AI in the beginning of the test process. So this can help us to find bugs, defects earlier in the test process, earlier in the development process, and therefore we can going faster. Okay. Think here in the last point on this slide. Not every tool survives. Think about support. So if there's eggplant and there to integrate some AI stuff, okay. But if you are going to I don't know, GitHub, and there's only one guy which have a good idea. Yeah, think about it if you want to use this. Okay. Yeah, on the last slide, I have the Gartner report from December 2021. And there we see the blue line, the delivery cycle time. I said it some time ago. We need to be more fast than we are right now, I think. And perhaps AI can help us there. AI in some test tools can help us there, and we get faster. So, thank you for your attention. I hope I give you a good overview about AI and the tools which are there and we can use right now. And here's one last slide from the Eurostar conference in 2019. Difference between machine learning and AI. If it's written in Python, it's probably machine learning. If it's written in PowerPoint, it's probably AI. And with these words, I say goodbye. Thank you.
So thank you very much, Nils, especially for the last slide here. So if I see that right, the tools and the examples you just provided, they will probably help us as testers, but they won't replace us as testers or do all the work we do as testers. I hope so.
Yes, that's right. They don't. We as the testers, we have to think on the automation bias. We have to think about the whole system in software. If we test AI, so we as a tester test the AI, there we have to think about performance testing, integration testing. We have to think on the requirements. And if we're using an AI tool, it's the same. Is the AI doing the right things and so on? There could be a bias in the data we are using, and then we will find only bugs we have found in the past and do no new bugs and so on. And we have to think about the result of the AI. Is the result right? So there must be testers than us, and we are looking beyond the end of the plate, I think.
So coming back to your quote, a fool with a tool is still a fool. So it's not the solution if we don't understand the problem or have a process in place and things like that, right?
Yeah.
So in my perception and maybe also in the perception of others, I think artificial intelligence in general is a very advanced topic for many testers and a very new and advanced topic. And maybe one can have great respect for getting into this topic, right? So what would be your recommendation here for testers who want to familiarize themselves with this topic? Just ignore it because they say, well, it's too advanced, or how would be good steps, or what would be good steps to get into it?
Yeah, we have to do. We have to deal with the topic. If we are too angry, then nothing will happen. And there are a lot of good YouTube videos, good blogs, of course, ISTQB, AI testing syllabus and the trainings to this course and so on. And then, yeah, we have to get a new topic, and then we can go into the topic. We can take a deep dive. Then we are a data scientist at the end, or we can, I said it, looking beyond the end of the plate and think on the whole system. And as a person in the project, okay, there's a little AI component, and therefore we can do this and that. I learned it, but think on the whole system. If the AI has not the right interfaces and the AI to deal with the system, then it's not possible to integrate the AI. Or what has happened when the integration testing is not working? What has happened when the AI is too slow to learn new things, and then the performance is going down and so on? That are all things we have to think about. And therefore, we have to deal with this topic, read a lot, learn a lot, do some courses, look YouTube videos.
Yeah, true. So speaking on the AI testing syllabus you just mentioned, which by the way is now also available in German for a couple of days or weeks. So You probably have also read the syllabus and worked on it as well. So what's your opinion of that? What do you think of the syllabus?
The syllabus is a very good starting point, I think, for testers which are not angry with mathematics. And the syllabus is, it takes it goes down and have a look at the neural network I show on the first slides, and then how is it working, what is the mathematical stuff there, and so on. So you have to deal with that. It's not only a glossary course where you learn some glossary terms and so on. You have many hands-on. So I haven't mentioned it right now. There's a tool called Jupyter Notebook, and with this Jupyter Notebook, you can do in the browser some neural network stuff. So you can program there a neural network, and then you can have a look what is happening with this neural network if I change this parameter, if I do another starting function, and so on. And this is done in this course. So it's more mathematical than some other courses in the
okay. And we have to cope with that, definitely. So last question, you are writing on the book for the syllabus. So how's the progress? When can I go to the bookstore and buy it? Next week?
It's a running gag, I think, for us testers. It's the software is
almost done.
Almost done. I have only one more function, and then it's the same with the book.
Okay. It already exists on your computer, right?
It exists. The progress is good. I think we have 50 or 60% or so. But it's a little bit to go. Perhaps it's the D-Punkt. What's that in English? I don't know.
The publisher.
The D-Punkt publisher. They want to have a look at too, and I think they need 2 or 3 months. So if we have finished at the end of the year, then perhaps coupon.
So good luck on that. And I know it's a lot of work from own experience, but it's worth it. So I'm really excited to hold it in my hands at the end of the year. So thank you very much, Nils. That was very interesting with you as our fourth guest today at our German Testing Board track at the A4Q Testing Summit. So thank you everybody for attending our track. Me personally, I had a great and informative afternoon. I hope so did you. And thanks again to all of our speakers. We had Matthias Hamburg speaking on metamorphic testing. We had Horst Pullman speaking on ISTQB and A-Spice. We had Armin Metzger here, who was talking on the GTB's occupational skill profile. And last but not least, with you, Nils, testing with AI. So thank you, everybody. Have a good night and see you someday later. Bye.
See you. Bye-bye.
Bye.